For homework, for homework, we're going to basically create a scatter plot and then the residual plot. So we're going to do both. So there's 6 questions on the homework, and let me pull that up for us. So here's number 1. I'll do number 1 with us, maybe even number 2 with us. They do take a little bit long. So we're going to first go ahead and make a scatter plot and line of best fit, and this would be of the actual data. So this would be of the data, right? So here, right, we're going to use our x will literally be the x, right? That's going to match up with the x for the data. And the y will be the y for the data. So this data goes from 10 to 80. I'm going to count by tens. 10, 20, 30, 40, 50, 60, 70, and 80. Right? We could keep going. And then the y's, I'm going from 350 up to 2100. So, you know, if I said if you take your biggest number and you divide by how many points I have, so 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So my biggest number is 2100, and we have 15 points here. So if you take a calculator and you do 2100 divided by 15, right, you'll get 140. So counting by 140, now I'm going to round that up to 150 and instead count by 150. Okay, I think that's a little bit better, is pick numbers that are easy. You can even round it all the way up to 200 if you want to. Always round it up, though. Never round down when you're doing this. So 150, 300, 450, right? 600, 750, 900, 1050, 1200. This part takes a little while. Okay. What was that at? Okay, 2250. Yeah, I was right. Okay, so there we go. So now we have all of those points, and now we can just kind of plot them. So at 10, we're going to be somewhere around 350, so a little bit above the 300. At 20, we're going to be somewhere around the 600. And you could have, counted by 200s, would have been fine, and you'll get a graph very similar. At 30, we're going to be at 850, so below the 900. Right, at 40, we're going to be at 1099. At 50, we're going to be at 1351, just above that 1350. At 60, we're going to be at 1601. At 70, we're going to be at 1849, so above that 1800 by just a little bit, right? Kind of 1850. And then at 80, we're going to be at 2099, so just below the 2100. That looks very, very, very close to being a straight line. Okay. So for my linear regression equation, right, I'm going to just kind of draw a line that I think kind of almost passes through all of them. Right? It might not be perfectly passing through all of them, but it's pretty close. And then, so that was my scatter plot and my line of best fit. But to do the other stuff, I am going to need to pull up Desmos. So I'm going to need to pull up Desmos and type these in. Okay, so here I have it graphed on Desmos, right? And it looks very similar. And so we'll use Desmos. We'll do the y1 tilde, and then we do m times x1 plus b. Okay. And this gives us our, I got to do the x1 and the y1 up here. Don't forget that. And this gives us our linear regression equation. And I got an R of 1. When you get an R of 1, that actually means it is a line. It's a perfect line. Okay, it does pass through every point. So whenever you get an R of 1, what that means is it literally passed through every single point there was. Okay? So we are going to go back over to our homework, and we will say that the linear regression equation was y equals 24.981x plus 100.857. And then it passed through every single point. So if you made a better line than mine, yours would have passed through every point. Okay, then for the residual plot, this is where it's a little bit harder. So this is where you have to do these predictions and these residuals. So what we're going to do is back on Desmos, we are going to create an equation. So we're going to do f of x, okay, f of x equals, and we're going to just type in that 24.981, right? That was our m, x, plus, and then that b, 100.857. So it should go straight over the other line, right? If I, take that off, they're the same line, right? All I did was I wrote this in terms of our function notation. I wrote that as a function, right? And so f of, right? And we would do f of 10, right? F of 20, f of 30, and I'll just kind of fill them out. But each one of these, right, that 350.667, right, we're doing that so that we can get that into our prediction. That was the prediction. So 350. I'm going to just round these to the nearest, it says round our answers to the nearest hundredth, so I'm going to do that. So that's 2 decimal places. So 350.67. The next one was 600.48. And then our next one was 850.29. Right? And so what we're doing, I'll fill out the rest of these. But again, the way that I'm getting those predictions is from Desmos. I'm getting those predictions on Desmos from this function notation, and then doing f of 10, f of 20, f of 30. Why am I picking 10, 20, and 30? Because those are the x values, right? Those are the x values, right? So we're going to make the rest of the predictions. Okay, and so, all I did was I just went to Desmos and I just kept filling these out. So I already wrote these for us, so you can just go ahead and kind of copy down my answers, but I didn't want to waste our time, right? And you can check yours on your own. I would highly recommend typing these into Desmos and doing exactly what I did, because you're going to have to do it for number 2 anyways. So if you do it for number 1, you kind of get that practice when you do it on your own for the next one. So now I want to get the residuals. How do I get the residuals? Well, I always subtract y minus the prediction. It might be useful to get a calculator out for these, right? Most of these we're not going to be able to do in our head. Now, Desmos technically is a calculator. So, you can type these in straight into Desmos, and it will just do the math for us right there as well. So if you want to do that, you could. So we would type in 351 minus 350.67 into Desmos, right? So 351 minus 350.67 into Desmos, and it gave us 0.33. I'm going to use another color here, so 0.33. And then I'll let you kind of do this on your own. I'll just kind of skip forward. But each time you're subtracting 601 minus 600.48, 849 minus 850.29, and we'll fill out the rest of this table. Okay, and so again, I subtracted all of these. Here are the results. And you guys can go ahead and pause the video, copy those down. But again, I would highly recommend that you just practice on your own. 601 minus 600.48, 849 minus 850.29, and get those answers. Once we have those answers, then we create the residual plot. Okay, and it's important to remember that on our data, right, our data, that is, the x and the y value. So that's the actual x and the y value. But on the residual plot, we keep the same x value, but for the y value, instead of putting the data, we put the residuals, right? What was the residual again? This residual is basically telling us how far apart is my data from my prediction, right? So now we're going to go ahead and graph these. And for this, it might help us, instead of counting, by ones, it might help us, if I look at what's my biggest residual, it's about 1.3, right? So it might even help us to count by 0.1 or, something a lot smaller. So unfortunately, there are only 10 points here. There are only 10 points. So counting by 0.1s is going to be a little tough, but 0.2 should work, right? So 0.2, 0.4, 0.6, and so on, okay? And so we'll kind of label our plot. And so here's my plot. I plotted, my x-axis. We're going to always keep your x-axis the same, right? It's the same x-axis. We're using the exact same x's that we used up here. But for the y-axis, the best way I can, recommend for you guys of what to count by is to find your biggest number. In this case, it's 1.28, and divide that by 10. So 1.28 divided by 10 is 0.12. Now 0.12 would be really awkward, right? I did 1.28, my biggest number, divided by 10, right? Or 0.128 really. That would be really awkward to count by. So just round it up to something that's easier to count by, 0.2. Always round up though, not down. If you round down, you're not going to actually fit all of your numbers. So that's my recommendation for what to count for on a graph. Okay. So now that we have that labeled, so once we have that, now we are going to go ahead and plot. So our x-axis is going to be the same x's. And now the y-axis, those are going to be our residuals, right? Those are going to be, this is our new y-axis for our residual plot. So this is our y for the residuals. So I'm going to just go ahead and plot those. So, at 10, we're going to do 0.33. So that's somewhere in between 0.2 and 0.3. At 20, we'll do 0.52. So kind of in between 0.4 and 0.5. At 30, we're going to do negative 1.29. So that's almost negative 1.30. So in between negative 1.2 and negative 1.4. At 40, we have negative 1.10. So right in between negative 1 and negative 1.2. At 50, we have 1.28. Somewhere up here. Then at 60, we have negative 0.53, somewhere down here. At 70, we have, I messed that up. I think I skipped one. Let me go ahead and fix it. Yeah, so I'd accidentally skipped, it looks like I'd skipped this point at 50. At 50, or 50, I'd skipped the 1.09. So I got that graph. 50 is 1.09. 60 is 1.28. 70 we have at negative 0.53. And then finally 80 we're going to add in at negative 0.34 at 80. Okay. So looking at this, right, does it make any sort of pattern? Not really. I don't see any pattern here. It doesn't make a flat pattern, but it also doesn't make any curved pattern, right? There's no curve here. So there's no curved pattern. So going back up to the question said, first, we're going to determine the linear regression equation. We did that with Desmos. Then we're going to construct a scatter plot and line of best fit. We just kind of did that by hand, right? Then we're going to do a residual plot. Well, to do that, first we had to get the predictions using Desmos and subtract. And then we had to figure out what we wanted to count by. And then we had to make this residuals plot, right? It takes a long time. And then lastly, we want to state whether this is an appropriate model for our data. So how are we going to do that? Well, we want to look at three things. We always want to look at three things, okay? The first thing you want to look at is your R value. We want our R value to be as close to 1 as possible. The second thing we want to look at is our data plot. And does that look like it might make a line? And the third thing we want to look at is our residuals plot. And what we're looking for here is we want to either see no pattern or we want to see a flat pattern. So we want to see either no pattern or a flat pattern. So let's kind of look at all three of those things and then figure out, if we think that this would be an appropriate model to use for a linear graph. So my R value is exactly 1. When you get an R value of 1, it's a line. Okay? So that's really good. Then our data plot looks like a line, and our residuals plot has no pattern. So all three of those were true. So I would say yes, a linear line or a linear model is appropriate because, and then, we would say R is equal to 1. The data seems linear. And the residual had no pattern. So these take a long time. Literally, I think I just spent as much time on number 1 as I did for the entire notes. So They do take a long time, so kind of plan accordingly. And because of that, right, what I'm going to kind of do is that I'm going to say the evens will be extra credit for this lesson. So the evens will be extra credit for this lesson. The odds I want you to do on your own, but don't just copy the answers. If you just copy the answers, you're not doing yourself any favors. We're going to have a test coming up on Tuesday. So the test for this topic is going to come on Tuesday. So if all you do is copy down the odds, you're going to fail those questions on the test. You need to know how to do these. So evens extra credit, and I will do number 2 with us right now. I do believe I was totally just sharing the wrong screen this whole time. That's my fault. So let me kind of come back here and make sure that we had that. So our R value is 1. I had said the 3 things we're looking for are R value, our data plot, which is this blue guy, which looks like it's a line, and then the residual plot, which we were looking to see no pattern, which we did. And so then I answered this as yes, a linear model is appropriate because R equals 1, the data seemed linear, and the residual plot had no pattern. So if you want to get a little bit of that extra credit, then I'll do number 4 with you guys. So when I'm doing number 4, first thing I'm going to do is graph this by hand. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these guys across, and my biggest number is 16. So if I did kind of 16 divided by 10, that's 1.6. I don't want to count by 1.6. I'm going to round that up to 2. And then same thing for my Y values. My biggest number is 656. Okay, if I did 656 divided by 10, that's going to give me 65.6. I don't want to count by that. I think hundreds are pretty nice to count by, so I'll count by 100s. Okay. And this is what our graph will look like once we plot it. So when we plot 2, 2, 4, 5, 6, 11, they all basically look like they're almost just touching the axis because 2 up to 100, it's basically going to be at 0, right? And then the graph kind of starts to go up. Now, remember, this doesn't really look linear. If you're thinking ahead, it probably looks exponential if you're kind of remembering that. But we're trying to go for a linear model. So what would be a line that goes through all of these? Maybe something like that. That would be my version of my best fit line. Okay. Now I went ahead and graphed this on Desmos for us already. And I did kind of that same scale, counting by 2s and counting by hundreds. And then we will get our regression equation. Y1 is approximately m times x1 plus b. Okay. And so our regression equation is right here. So our m is 37.97, and our b is negative 194, and the r is 0.81. So that tells me that at least, the r being 0.81, this line is pretty close to the data. Okay, I'll zoom out a little bit so we can see it a little bit better. But, definitely this data looks like more exponential than linear, but we're still going to, answer our questions and look at how does this relate to a linear regression. So with linear regression, we'd say y is equal to that 37 point. It asked me to go to 2 decimals, so 98x minus 194.54, right? I got that from Desmos. Then next, what I would do is I would get all of my predictions. So I get all my predictions. I already filled them out for us. But remember that the way we get these predictions is on Desmos, we have to then rewrite this as f of x equals, and I'm going to do 37.9762x minus 194.536, kind of just doing y equals mx plus b. And then now from here, I can do f of 2. I get negative 118. F of 4. Right? F of 6. If your numbers are a little bit different than mine, I did this exactly right here. And then when I was doing my answer key, I didn't do it exactly. I did a rounded number. So like I got negative 118.5. And actually on my answer key, I kind of messed up. I rounded it a little bit. And I got negative 119. So this answer actually isn't quite as good as having the negative 118. The negative 118 would be more precise. But honestly, we're going to be okay. So now we're going to subtract 2 minus, once we get all of these, right? I do this for 2, 4, 6, 8, all the way up to 16. Then I'm going to do 2 minus negative 119. When we subtract by a negative, it actually adds, right? So that's why we got 121. And now we need to make our residual plot. So what's the biggest number I have here? The biggest number I have is 242, right? And if I divide this by 10, right? 242 divided by 10 is about 24. I don't want to count by 24s. Counting by 25s is going to be much nicer. So my x-axis, I'm going to keep the same, right? 2, 4, 6, counting by 2s. And my y-axis, I'm going to now count by 25s. Okay, 25, 50, 75, 100, and same thing on the negatives. So there's our graph fully labeled. And remember that when we do our residual plot, the x-axis stays as the x-axis, and then the residuals is my y-axis, right? Whereas when I was doing my data plot, my scatter plot, we had used the x and the y for the, this is kind of for the scatter plot, right? So that's for the, the data scatter plot. And then the residual plot uses the residuals, but it keeps our same x-axis. So now we're going to go ahead and graph all of these. I'm going to just kind of graph them quickly for you guys. And so my plot looked something like this guy. And you remember when you're graphing these, like 121, I'm going to go to 125 and just go a little bit below 125, right? For 48, I'm going to go to 50, go just a little bit below 50, right? And so, just do your best. And this definitely looks like it does have a pattern, okay? I know some of you guys are going to try to think it doesn't, but try to play connect the dots. Could you connect the dots and make a curve? Okay? So if I connected the dots, right, I could kind of make this be kind of curving down and then curving up, right? Now, it's not a perfect parabola, but it's definitely a curved pattern. That is a curved pattern. Okay? So that's kind of what we're going for. Now, the last question, now that we filled all this out, is do we think a linear model is best? Now, the R, right, when we did R on Desmos, we got R was 0.82, right? 0.82 is a really good R. Like that's, hey, this is matching our data pretty close to the line. So, the 0.82 is good. You cannot use that as a reason for why this wouldn't be a line. And then if I go ahead and I look at my, data, I think it looks more exponential. So we could use that as a reason. And when we look at the residual plot, it's definitely a curved pattern. So we could also use that. So I'm going to say, no, the R was close to 1, but the scatter plot looked exponential, and the residual plot had curved data or pattern. We'll say a curved pattern, use proper English. So a linear model is not appropriate. And so this is what our answer should look like. These are going to take you a long time. Okay, they do take a very long time, which is why I already did number 1 for you. And if you want to do the extra credit, I did number 4 for you. So all you actually need to do for homework is go ahead and do number 3 and do number 5. Then the other part of the homework is the Mathia. But it's only 2 questions like this. Now, if you want to do a little bit more for extra credit, you could also do 4 and 6. Okay. Email me if you have any questions. Check your answers for numbers 3 and 5, but please, please, please do not just copy them. We are going to have a practice test on Monday, and then we will take the real test on Tuesday. Okay? Enjoy your guys' weekend, and I will see everyone on Monday.